Okay, Assalamualaikum and hello everyone. Untuk kelas hari ini kita akan masuk kepada subtopik yang kedua dalam chapter 11 iaitu radioactivity. Okay, kita pergi pada learning objektif yang pertama which is 11.2a. We have to explain alpha, beta plus, beta minus and gamma decays. Okay, so apakah alpha, beta and gamma decays? So first thing first, dalam nota kamu dikata radioactivity ataupun radioactive decay is disintegration of unstable nucleus to a more stable daughter nuclide with the emission of alpha, beta particles and gamma ray. So dia ialah disintegration daripada unstable nucleus. So kita belajar in 11.1 nukleus yang mempunyai binding energy per nukleon yang rendah dia ialah unstable. So kalau unstable maksudnya dia senang decay pada bila-bila masa. Okay, so the disintegration of unstable nucleus to a more stable daughter nuclide. Maksudnya daripada unstable ini dia akan disintegrate kepada more stable nuclide. Okay, daripada unstable nucleus dia akan disintegrate kepada more stable nuclide. So itu ialah radioactive decay. Okay, so radioactive decay is spontaneous and random. So dia ialah proses yang spontaneous and a random process. Okay, so what is mean by random? So random means the time of decay of each atom cannot be predicted. Sebab dia kata random, maksudnya tiba-tiba dia nak decay supaya dia lagi stable. Okay, so it cannot be predicted. Okay, and what is mean by spontaneous? Mean it happened by itself without external stimuli. The decay is unaffected by normal physical or chemical process such as heat, pressure and chemical reaction. Okay, so spontaneous ni maksudnya secara tiba-tiba dia decay dan dia happen by itself. Dia tiada affected by the normal physical ataupun chemical process. Maksudnya you tak perlu pun bagi physical process ataupun chemical process, tak perlu pun panaskan dia, bagi pressure ataupun chemical reaction. Dia akan decay dengan sendiri. Okay, so that is mean by random and spontaneous decay. So kalau dia random and spontaneous daripada unstable nucleus kepada more stable nuclide dan menghasilkan alpha, beta dan gamma, so dia ialah radioactive decay. Okay, so ada 3 radiation yang dikata tadi which is alpha particle, beta particle and gamma ray. So alpha dia ialah particle. Okay, dia mention particle. Beta juga dia particle which is you can have beta plus and beta minus particle. But gamma dia ialah rays. So gamma ni dia ialah cahaya biasanya. So kita belajar gamma rays. Okay, particle ini dia yang boleh kita nampak lah. Alright, so we go to the first one which is alpha particle. Okay, alpha particle simbolnya ialah alpha sebab nama pun alpha. So it said here that an alpha particle is a 42He. So alpha particle ialah simbolnya 42 helium. Nucleus consists of 2 proton and 2 neutron. So kita tahu kalau soalan mention alpha particle dia ialah 42He. Dia juga bersamaan dengan alpha particle. Okay, it is a positively charged particle. Ingat, dia sentiasa positif. Okay, its value is positive 2e with mass of 4.00150 atomic mass unit. Okay, alpha particle has least penetrating ability. It can be blocked by a sheet of paper. Maksudnya bila you ada alpha particle, you letak sehelai kertas, alpha particle tak boleh tembus. Okay, its motion can be deflected by both magnetic field and electric field. So we have learned in chapter 4 magnetic field and we have learned in chapter 1 electric field. Disebabkan alpha particle ini bercharge to positive E, dia boleh attracted by the magnetic field and by electric field. Okay, when a nucleus undergoes alpha, it decays. Alpha decay, it lose 4 nucleon which is 2 proton and 2 neutron. Okay, for example, equation untuk alpha particle ialah you have unstable parents which is this one ialah unstable. Okay, so unstable. dia nak jadikan diri dia stable, dia perlu melalui radioactive decay, which is dia akan menghasilkan 4-2 helium, which is 4-2 ini kita tahu dia ialah alpha particle, dan dia akan menghasilkan daughter nuclide yang baru, which is yang daripada parents dia perlu tolak dengan 4 dan Z perlu tolak dengan 2 sebab dia dah hasil kat sini. Kalau kita belajar chemical reaction, before and after process dia kena seimbangkan. So A dengan Z ni bilangan dia kena seimbang. Okay? Dan step proses akan menghasilkan energy release, dan simbol untuk energy release ialah Q. Okay. For example, here I have aurum. Aurum antara nukleus yang unstable, which is aurum dia punya A197, dia punya Z ialah 80. Aurum unstable. So dia nak jadikan diri dia stable, dia menghadapi ataupun dia melalui alpha decay. So alpha decay obviously you can terus tulis 4-2 helium. Daripada 4-2 197 tolak 4 jadi 193, 80 tolak 2 jadi 78, which is 193 dia ialah aluminium. Dan of course dia akan release energy. Okay, so this is alpha particle. Okay, next. We go to the beta particle. Beta particle simbolnya ialah beta. So, beta particle has same mass as an electron. Okay, so mass of electron ataupun 0.00549 atomic mass unit. Okay, beta particle can be electrically positive, which is we call as positron, or negative, beta minus or negatron. So, simbol yang untuk positron ialah 0 plus 1 B, beta plus or electron positif. So, dia positron. Kalau negatron, dia negatif, B minus dan negatif E. So, beta particle has moderate penetrating ability, which is kalau kita ada beta particle, dia boleh diberhentikan by a few millimeters of aluminium. Kalau alpha tadi sehelai kertas, tetapi kalau beta dia few millimeters of aluminium, and its motion can be deflected by both magnetic and electric field. Kenapa dia boleh deflect oleh magnetic and electric field? Sebab dia ada charge. Charge positif dan charge negatif. Okay. So, two type of beta decay. The first one ialah beta minus decay. So, it occurs when unstable nucleus has too many neutrons compared with number of proton. Okay, dia ada too many neutron. Okay, compared to number of proton, neutron is converted into a proton to create a stable daughter nucleus. So, terlalu banyak neutron, dia nak jadikan dia stable. So, dia terpaksa di-convert menjadi proton. Okay, so kalau beta minus, ini unstable parents, dia mengeluarkan beta particle dan this is the daughter nucleus. Dan dia also release energy. Okay. Tetapi dalam beta, kita ada satu lagi simbol which is this one, which is we call as anti-neutrino. Bentuknya macam huruf B, tetapi dia ada bar dekat atas. Right. For example, radmium. Radmium, dia unstable. So, untuk jadikan dia stable, dia melalui beta minus. So, kalau beta minus, dikeluarkan beta particle, which is beta particle ialah 0 negatif 1 E. So, ini ada negatif 1, 88. So, sini anaknya kena jadi 89. Okay, right. So, itu ialah beta minus. And we also have beta plus decay. So, it occurs when unstable nucleus has too many proton. Kalau minus, dia too many neutron. Kalau beta plus, dia too many proton. So, yang proton itu terpaksa di-convert menjadi neutron. So, equation kita, this is unstable parents. Dia terpaksa melalui proses beta plus, which is akan dapat positron. Dan dia menghasilkan daughter, which is Z tu kena tolak dengan 1. For example, kita ada protactinium. So, protactinium 230-91, dia melalui proses beta plus. So, dia akan mengeluarkan positron 90. Sini akan jadi 90 supaya dia balance. Ini 91, 90 tambah 1, 91. Okay, macam tadi, 88. 89 tolak 1, dia akan dapat 88 balik. Okay. So, dia juga menghasilkan which we call as a neutrino. Okay, so that is beta particle. And the next one we have gamma rays. So, gamma kalau kamu perasan dia bukan particle. Dia menghasilkan ray. Okay, ray ialah sinaran. Okay, so gamma ray is a high energy photon. So, soalan mention dekat sini dia ialah photon. Photon ialah cahaya. Okay, kita belajar in chapter 9. Photon ialah cahaya. High energy photon. Photon yang mempunyai tenaga yang sangat tinggi. Okay, so kita dah belajar E is equals to HF. Okay, it is uncharged and zero mass. Sebab dia ialah cahaya. Cahaya tak ada charge dan tak ada berat. Emission of gamma rays does not change the parent nucleus into a different nuclide. So, gamma rays, dia tak mengubah parents tersebut. Kalau kita tengok alpha dan beta, dia mengubah parents. So, parents ini terpaksa menjadi nukleus yang baru. Tapi kalau gamma, dia tak mengubah parents. So, gamma ray has the most penetrating ability, a few centimeter of lead. Okay, kalau alpha, a sheet of paper. Kalau beta, a few millimeter of aluminium. Tetapi kalau gamma, a few centimeter of lead. It cannot be deflected by any electric field or magnetic field. Kenapa tak boleh di-deflect? Sebab dia uncharged. Okay. Gamma rays are emitted when an excited nucleus jump to a lower energy level. So, we have learned in chemistry, you ada energy level. Okay. Kalau you ada satu nucleus yang jump to a lower energy. So, what will happen? Dia akan release photon. So, photon tersebut dalam bentuk ray. So, kita panggil dia sebagai gamma. Okay. Dia kata when an excited jump. So, excited state dekat sini excited state. So, dia jump dekat lower state, dia akan release gamma ray. So, macam kita tahu tadi, dia kata dia tak mengubah parents. So, parents asalnya AZ. Akhirnya juga akan menghasilkan AZ, tapi dia mengeluarkan gamma rays. Okay. Where the asterisk mean excited state. So, we have learned in chemistry, excited state turun ke bawah akan mengeluarkan cahaya, which is that cahaya ialah gamma ray. Gamma ray, dia mempunyai high energy wave. Okay. So, we have to compare the properties of alpha, beta and gamma. So, alpha, dia ialah bercharge positive 2. Sebab apa? Dia ialah helium-4 tu. Beta is either positron or positron ataupun negatron. Okay. So, the charge positive 1 or negative 1. But gamma, it is uncharged. Okay. So, diffraction by electric field and magnetic field, yes, yes and no. Kenapa dia yes? Sebab dia ada charge. Dia ada charge. This one pun kenapa yes? Sebab ada charge. This one no, sebab dia uncharged. So, diffraction by electric field and magnetic field. Okay, ionization power, it is very strong sebab dia sangat ion, positive 2. This one dia moderate sebab dia positive or negative 1, and this one is very weak sebab dia uncharged. Kita belajarkan in chemistry ionization. And penetration power, it is very weak sebab kita letak selai kertas pun alpha particle kita boleh stop. Moderate, few millimeter of aluminium, and it is strong kalau kita letak untuk alpha, gamma, few centimeter of lead. Okay. Ability to affect a photographic plate, yes, yes and yes. Produce fluorescence, yes, yes and yes. So, this is the comparison between alpha, beta and gamma. Okay, so this is the first part in 11.2. In the next video, I will share you about the next learning objective in 11.2.